Okay, good afternoon. Welcome to
FamilyMath307a.
FamilyMath307a. You guys just got back from vacation today, right?
Yep.
And you missed math more than anything else when you were on vacation, right?
No.
No? What did you miss more than math?
Ice cream.
Ice cream? You didn't have any ice cream on vacation?
No. I miss it.
You missed it? Okay, well, yesterday I saw a really cool article written by our friend Evelyn Lamb. And it was about topology. And I don't think we've ever talked about topology, have we?
No.
No. I thought we'd just talk a little bit about it today because it's a really cool subject. It's the study of shapes. And what do you think is the study of shapes? What would you normally have called that?
Well, geometry.
Geometry, yeah. So topology and geometry study shapes in two totally different ways. So topology tries to understand when two shapes are the same. So a simple example might be, you could say, well, those are both triangles.
Yeah.
Something like that. And you would say, well, they're the same because
They're both triangles.
they're both triangles. In geometry, you might want to go a little step further, and when might you say two triangles were different?
Well, when they don't have the same angles.
Okay, yeah. Where else?
If the side lengths are the same?
Side lengths aren't the same, yeah, good. Good. So the first example people like to talk about in topology is a coffee cup and a donut. So that's what I have here,
Or a bagel.
but in this case it's a bagel. And mathematicians like to say these two are the same because they can be deformed into each other. So if instead of being made out of porcelain or whatever this is made out of, and bread, let's pretend they were both made out of Play-Doh? How could I transform the bagel into a coffee cup?
Well, you could roll them up into spheres. You could roll the bagel into a sphere, and then you could roll the coffee cup into a sphere,
Okay.
and then you could see if they had the same volume.
Oh, that's a very interesting idea. Okay. Do you
Or-
think every way you rolled them up would result in the same volume?
No, but if you rolled it up into a perfect sphere,
Uh-huh.
then you could have the same then you would have the same volume.
Cool. What do you think? How might you be able to see if these two shapes are the same?
Well, if you get rid of the part of the hole on the bottom and extend this up,
Uh-huh.
then you get sort of a shape. Except you have to widen it a little.
How? What do you mean? I'm interested to hear a little bit more about that idea.
Well, if you take the hole on the bottom and close it up and
Uh-huh.
just take this and stretch it upward,
Okay.
and then it would result in kind of the same shape.
Interesting. Very interesting. What are some of the things that these two shapes have in common?
Well, they both have
Holes.
holes in them.
Where?
Like this is sort of a hole,
Okay.
and that's a hole.
All right. Well, one is sort of a hole. You're saying the other one's
Yeah.
definitely a hole.
Well,
But this doesn't go all the way through.
Yeah.
they both have circles on the top.
Yeah, they both have curves.
Okay.
And they both have.
And if you slice it down the middle
Mm-hmm.
and just take a thin piece out of each, you get a rectangle. Like if you imagined you put like a sheet of glass
Uh-huh.
here, this would end up being a rectangle.
Oh, interesting.
And this one would end up being a rectangle. Well, that one's more of a trapezoid.
Okay. Well, that's fine. It's very interesting. Anything else that's similar about these two shapes? That why mathematicians might say these two shapes are the same, or they could be deformed into each other?
They're both three-dimensional,
Okay.
and they do have linear edges.
This one doesn't actually have a hole in it.
Yeah, that's interesting. This one, you think definitely has a hole.
Yeah,
And
but
that
this one doesn't.
You don't think that one does have a hole?
I mean, it sort of has one here.
Where?
Here.
Ah.
So you could sort of like move the mass around this hole and make the hole a circle.
Oh. think you could turn this into this? And what would turn into the hole in the bagel?
It was
So
this one.
this part, like you
Yeah.
have to slide this up and then put the mass around it.
Cool. That last way of thinking about it is the way mathematicians think about it.
Hmm.
Because you can imagine sort of just what you said, kind of pulling the mass around, and then this hole always stays there. You can't really get rid of that hole, but it turns into that hole. Great. You see that connection?
Mm-hmm.
Yeah.
Okay, cool. Now let's talk about what Evelyn Lamb was talking about.
Okay.